everybody, today we are going to talk about simple harmonic motion. I'm Harry, he's Wei Han. He's going to solve simple harmonic motion of differential equation.
And we know that acceleration is directly proportional to displacement, and therefore you need to add a constant here to make this equation. And we know that acceleration is same as the change in velocity, which is dv over dt equals to negative k squared over negative k squared times x. And dv over dt, we can use the chain rule and write it in dv over dx times dx over dt. And this can cut, and dx over dt is the change in displacement, which is v. And then we can move this dx to here and become an integration. Then we integrate v and integrate negative k squared x, and you will get v squared over 2 and equals to negative k squared x squared over 2 plus c. And this is at the top maximum part of the sine graph, which is the simple harmonic motion. At this part, this is the maximum displacement, which is the amplitude, maximum amplitude. We write it as a, and at a, the velocity is a because it is changing in direction. So x equals to a and v equals to 0, and we can sub this into this equation, and you will get 0 equals to negative k squared a squared over 2 plus c, and c is k squared a squared over 2, and you sub this back into here, then you get this, then you times 2 for everything, you get this, then you square root this thing, you get k squared times square root a squared minus x squared. Then v is also the change in displacement, dx over dt equals to k times square root a squared minus x squared. Then you move this term with the x to here, then you get a squared minus x squared power negative half, and dt to this side, integrate k in terms of t, or with respect to t log. Then we let x equals to a sine u. X equals to a sine u. Then you put this back here in here. Then you expand. Then you expand. It will become a squared sine square u. And we need to differentiate x with respect to u. You will get a cos u, because in differentiate sine you get cos, and dx is equals to a sine u du. So dx here equals to a cos u du. So you integrate this with respect to u now, and now you do the algebra, expand, then you get this, then you take out the common factor, which is a square here, take out, then you left 1 minus sine square u. 1 minus sine square u is also equals to cos square u. Then you can power the negative half. A square power negative half, you get a power negative 1, and this cos square u power negative half, you get cos power negative 1, which is 1 over cos u. And here, this a cos u is this one, then it will cancel out, and you get 1. And you can integrate 1 with respect to u, you get u. Integrate k with respect to t, you get kt plus c. Then you can sub this u equals to kt plus c into here, this u. Then you compute that x equals to a sine KT plus C.
Okay. So, simple harmonic motion describes any phenomenon that fluctuates. Fluctuates means the graph moving up or down. There are a few examples, such as heartbeat, tides, sound waves, radiation, and lastly, temperature.
Okay. So this is a sine graph. It's part of the simple harmonic motion because it keep on going up and down. And this is an example of simple harmonic motion equation, and this is the graph. And as the graph show, amplitude is the Owen, Wei Han. Amplitude 是什么啊? It is the maximum displacement from哪里啊?
Okay, so from the equation A sine bx plus c, the c represents the shift of the graph to the left or to the right. So if the c is pi over 2, the graph shifts to the right by pi over 2. So it starts from this point here, which is pi over 2. Okay, so this question is inside your worksheet. So it's the question.
Wait. We use the worksheet question.
Yeah, why not?
Can I?
This question can be seen in your worksheet, which is question 1D if I'm not mistaken. If you compare the cos and the sine, so this one is here, this one is here, you can see that this and this are constants, which are square root 3 and 1 respectively, because this one is cos, so you compare this to this, this one is sine, you compare this to this, okay? So, using this simultaneous equation, you can find this equation and this equation from here and here. Using CAS, you just type in the solve, and then your two equations, comma, your variables, and you can see that your amplitude is 2, and your alpha is this degree. But there's an alternative way to do it. Just take the two constants and just do it with Pythagoras theorem, and you get it.